Okay. Now, good morning. Now we are going to learn about concave mirror, image formation by a concave mirror, right? Now, see here, generally as in the state cell bus, the object is taken always on the right side. I am taking object on the right side. Okay. So now we'll do case one after the other. The cases. See, concave mirror means the silver paint is done on the what do you call, outer side, and the reflection takes place on the inner side, right? So now what I will do, light ray will come like this parallel to principal axis like that. Now what we will do, first case, which is the closest uh, object distance is here. For example, the object is kept between F and C. For example, if you extend like this will be C, somewhere here will be midpoint of P and C will be F, like that. So we are taking the object AB at means between mirror and focal point. Focal point you can say principal focus or focal point. P means pole you can say, or otherwise you can say mirror itself. Okay, so here what we can do, here you can write like this. What you can say that in which case you are drawing means you have to say like this. Okay, what case 1, when object is kept or object is at, okay, is between mirror and F, between, so you can say mirror means which mirror, concave mirror, and F means what, a focal point, focal point you can say it as F, right, or principal focus. Okay, the meaning is the same, right? Now what I am saying, the light ray, we have to take any two light rays, right? So generally what will happen, this in this case generally you will get a image, okay, like shaving mirror case, you will get a image here. Okay, so what I will do, in order to give the space, what I will do, I will draw from here generally. So what I will do is I will take like this, where I will draw is the image I will take from here in this case. Why? Because we need a little more space, so that is the reason. This is a shaving mirror case, okay, when the object is kept in between mirror and focal point. So for example, this is a concave mirror, okay, and the object is kept at between, means here P will be there. So if you extend somewhere here you will get C and this will be F. So the object is kept between F and C, so this is AB, right? So now the light ray which is coming parallel to the principal axis, like rules I said in that way, so that light ray will go like this along the principal focus, and the light ray which is going along center of curvature, it will go like this. So these two light rays, if you extend like this, they appear to come from a point like this. For example, this also you extend, if you extend this, these two light rays will appear to come from a point here. So this is called as what this point is, the point of intersection of these two light rays will give you the image, and you can say this as A dash B dash. Okay, so this is the way you have to, okay, so this is the light ray, okay, it is going like this and it is coming like this. Okay, so this is about shaving mirror. And when you write this, generally you have to write the position. So where the image is formed, position of image you write. Position of image is image is formed behind the mirror, you write. Okay, image is formed behind the mirror, so you can say simply like this, behind the mirror on the other side of object, okay. Second one, see, position of mirror is done. What about nature of image? Nature, see, whenever the light rays are, means for a person who is seeing from here or here, for his eye it will appear as if the image is formed inside the mirror. So this is called as nature of image. And here what will happen, here the light rays appear to come from, so you would say it as virtual and erect, right? And now this is about, now size. What is the size of image? Size of image is big, right? So you can say it as the image is enlarged. Okay, so this is about case number 1. Okay, this is an important case in what do you call, concave mirror, that is case 1. Now we will go to the next, means you are taking object closer to the mirror, then next step we will take at F, and next step we will take at in between F and C, and next step we will take at C, and then beyond C and at infinity, like that. Means that is the reason 6 cases will be there in concave mirror. Means it means that if you change the position of the object, the nature of the image, okay, this all will change, position of image and all will change. Okay, so but whereas in convex mirror what will happen, if you change the position of image, you won't get any change in the position of the image. Okay, so you will get only one kind of image. That is the reason in convex mirror generally one case will be there, but say one more case in some books it will be there, that is when object is at infinity, point size object will be formed, image will be formed. So that we will see afterwards. Okay, now we will go to the next step. Say I am rubbing this. We'll if you want, if anybody want, they can pause the video and see how the light ray and what is the nature and all, what is the size. Then we will go to the next step. Now see here, we took the object from P and F, means you have to go away from the mirror, you are going like that. Okay, as this state syllabus is giving, so I am doing like that only. So we have to take the object away from the mirror. Case number 2 will take. What is case number 2 is when the object is kept at, when the object is kept at F. Say this is the object is kept at F, this point is F, for example, this point is F, object is kept at F. Then what will happen, the light rays which are going like this, for example this is F, same distance you take C. Okay, so if you extend it somewhere, I think you may get a C like this. Okay, right. Now the light ray which is coming and going like this, it will go like this, and the light ray which is coming like this, it will also go like this. These two light rays are parallel, so generally parallel light rays will never meet. So what you have to take it as, you have to consider that they meet at a point called infinity. So that is the reason here you are right. What you are right, position of image means position of image at infinity, or right, at a infinity. And anyhow, okay, so the size will be anyhow diminished, so you are right, diminished. And the nature of image is light rays really meet, so you are right, real and inverted. Nature of image, you are right, real, inverted, and real and inverted, you write real and inverted. Whenever you are using only one mirror or one lens, you real means compulsory inverted will come. When real will be erect, image will be that when you use more than one optical device, like one mirror or two mirrors or one lens and one mirror, like that. So whenever you are using only one, real will be always inverted. Now size of image, size of image will be generally, it will be magnified only, enlarged only. Okay, now we'll go to the next case. The case is this case, anyhow you have to write like this. Case number 2. Okay, when the object is at F, means at F means at focal point or principal focus. In some books they will say it as principal focus, in some other books they will say okay, at a focal point. Okay, now we will go to the case 3. Okay, case 3, case 4, case 5. Just what I will do, 5 and 6 I will write. Okay, and I will just show you how it happens. Okay, and I will write the points. Right, now we will go to the next case 4. I think case 4 I can draw here. Let me sorry, case 3 I can draw here. So case 3 will be when the object is between F and C, that generally this will be you will get enlarged image only. So let us see here, I think it will fit, we can try here. See what I am saying is, here the light ray will come like this. Okay, for example somewhere here you will get C. Okay, so rub this, so this might be F, between F and C you take an image, so like this will come, it will go like this. Okay, and another light ray which is going to pass from C, it will come like this. Okay, so these two light rays will meet somewhere here. For example, another light ray which is going from F also you can take like this, for example. Okay, so for example you can take like this. Okay, so incident ray how it is passing, and after reflection how it is passing, and incident ray how it is passing, and after reflection how it is passing. Okay, like that. So now you can write the position where it is from. So now write position of image. What is the position of image? The position of image is, it is beyond C. See, same way nature of image, it will be what a real. Why? Because the light rays are real emitting. Okay, and what is happening, the light rays are real emitting, so real image. And size, it is, see, the size of the object image will be bigger than object, so you can write enlarged. So you can write enlarged. So you can say it as nature of image and size of image. Okay, size of the image, like that. Okay, so 1 2 3 is done. Fourth case what we will do is at C, means here the object is between, the object is where, object is between F and C. Okay, fourth case what we will do, when the object is, case 4 you take for example, when the object is between okay, between, okay, when the object is at C, will take at C. Okay, so in this case what will happen, the image will be formed of the same size as that of the object. For example, this is C, this is F. Okay, so for example, you are taking the object at C, so the light rays will, see how much you have, that much only, means the light ray will come and meet here only. So the light ray will come like this and it will meet. So here if you take this position as C and this position as F, okay, this is AB as the object, and here A dash B dash as the image. Okay, AB as the object, and here this point is C, like that. So then you keep the arrow marks like this. Okay, so the light ray is coming like this and reflected light ray is going like this. So here also you can write the nature. For example, say what is the position of image, means at C you write position of image at C, and what is the nature of image, real inverted. Okay, and what is the size of image, means same size. Okay, then beyond C and at infinity, only two cases we have to do. Okay, so now nature of image and size of image. Okay, this. Now I'll rub this. If you want, you can pause it and see what is the case and all. So case 2 3 4 is done. 5 6 I will do. Okay, beyond C and at infinity, when the object is at infinity, then what we can do, we'll go to sign convention. Okay, and convex mirror cases and sign convention. Okay, now case 5. See, generally when you are learning, you have to learn the table in the concave mirror table in the textbook. Okay, and if you remember that table, these are all ray diagrams you can remember. Definitely light, if you don't learn well, another lesson light for refraction is also there. So even you won't understand that also, and you may lose the marks. That is the reason you have to learn light thoroughly. Why? Because if you learn one lesson, the other lesson will be a little similar. That is the reason. Right, now coming to the next, case 5. What is case 5? When the object is beyond C. When object is beyond C. Right. So see, for example, I am saying the concave mirror is like this. Okay. For example, if I am extending, this is C. Okay. So the object is beyond C, means here will be there, right? Okay. The light ray which is, so what is happening when the object is beyond C, the image will be formed. Okay, the image will be formed between C and F. Between C and F means the light ray which is coming parallel to principal axis will go like this. This is F, and the light ray which is going from C, it will retrace its path. Okay, so here you will get image like this. So this is A dash B dash. So image is appearing smaller than the object. So generally you have to call this as like this, and you can say like this. What size of the image is between size and position of image. So position of the image will be between F and C. between F and C. Okay, and what is the nature of the image is real and inverted, and the size of image is diminished you can write. And last case, okay, case 6, what we will do when the object is at infinity. Generally it is not given in your textbooks. When the object is at infinity, for this I will do two ray diagrams so that you will understand. See here, when the object is at infinity means somewhere at infinity means when from infinity you don't need to take object. Why? Because the parallel light rays will come, so those light rays will meet like this. Okay, from here also parallel light rays coming and this light ray is meeting at F. So here point size diminished image will be formed. So like this you can take, understood? So this is one case you can take, or you can draw the ray diagram for the object at infinity like this also. What you can do is you take the concave mirror and you can take a light ray like this. The light ray which is coming like fourth rule, and the light ray which is coming parallel to the parallel to this light ray like this, like from infinity object how the light ray will come like this. So this light ray, okay, so another light ray also will go like this, but these two will meet at a point here. Okay, these two will meet at a point here like this, and this point is nothing but F, means at F only they will meet at the position, and you can take the object like this. You can say the image is diminished here. Okay, why? Because from infinity when an object is coming, from infinity something is coming, it means that some mountain image or something like that you will take. So this will be bigger than this, so that is the reason you have to say it as the image, the object will be bigger than image, so you have to take it as a diminished image only. Okay, now what is the position of image means you have to write like this. Position of image is at F. Position of image is at F. At F you take, at F means at a focal point, and the nature of image is real. Nature of image is real and inverted, and the size of image will be highly diminished. Right, now we'll go to the next convex mirror cases. If you want the video you can pause it and learn, and two more cases I will say, then I will go to the sign convention. Okay.